Welcome to the first video of Indice. Today we talk about Indice, what is it, and how to define it, and how to apply it. Okay. So Indice is not a new operation. It means this is an x square, or x to the power of 2, and it means x times x. It's x cubed, or x to the power of 3. It simply means x times x times x. And that is Indice. So why do we need Indice? So first, a safe space. So imagine x to the power of 50. You have to write 50x or multiply together. And secondly, it can be used to express the exponential situation. So let's see. So imagine we are planting potatoes. Okay. It's a potato field, and to start with, we have one potato to begin with. So we have one potato, and then we plant it in the soil. So we water it, give it good conditions, and then after one season, we get 5 potatoes back. Okay. And then for science purpose, we harvest all of them. We count 5, and then we put them back. We plant all 5 of them back. Okay. So what will we get next season? 5 times 5, right? If this land give a multiplication of 5 times of potatoes, so if we plant the 5 back, we will get 5 times more, 25. So 5 here is called the exponential factor, and the 1 here is the initial value. Okay. And most importantly, this can be expressed in this form. This is 5 to the power of 1, which is what happens after one season, the total potato we have. And then this is 5 to the power of 2. So this is what we have after 2 seasons. And this is 5 to the power of 3. And this is what we have after 3 seasons. Okay. So then we can just write 125. So why write this then? So if written in this form, it means that some exponential change has happened. Okay. So it can be either exponential growth or exponential decay. But today we focus on exponential growth. Okay, everything is increasing. And we can, or what if we buy 2 potatoes at the beginning? Okay, since we are planting, why don't we just start with more? Then we'll get more, right? So let's say we start with 2 potatoes. It's the same soil, it's the same conditions. So we have 2 potatoes to begin with, and after one season, it's multiplied by 5, so we get 10, or 2 times 5 to the power of 1. Okay. And in 2 seasons, 5 times more, 3 seasons, 5 times more. And the situation can be expressed in this form. Okay. And we don't have to calculate every time. Or let's say, we want to know what happened after 10 seasons. Oh, then it is 2 times 5 to the power of 10, right? Yeah. So, but in here, why don't we see the 1 times? Yeah, it is 2 times here. Oh, because 1 times does nothing. So if we do not see the 1 times, or do not see the initial value, which means the initial value is 1, because 1 times does nothing. It's omitted here. But we cannot omit the initial value here because it does something. So that's why we see a 2 times here, but not the 1 times here. Okay. The 1 times is omitted. Okay. So it's an exponential situation that can be represented by Indice nicely. And let's look at some rules to help us calculate the values involving indices. Let's go here. Okay. So one of the this is one of the law of indices, or some rules, or actually we can regard it as some shortcuts. Yeah. So this is x to the power of a times x to the power of b is equal to x to the power of a plus b. So what does that mean? Let's say we are using 5x as the exponential factor again. So we plan the potato for 2 seasons. And then, we want to predict what will happen if we plant it for 3 more seasons. Every season we plant all the potatoes back on the field. Okay, we invest all the potatoes back into the field. Okay, so then, which means it's equivalent to doing it for 5 seasons. Right? So then it is, just add up the 2 and 3 at the index. So this is the power or the index, and the power will be 5. Okay. So why does it work like this? If you break it down and look at the numbers, this is 5 times 5 for the 5 square. This is 5 times 5 times 5 for the 5 cube. Okay. So then, it's multiplying. So the order of multiplication doesn't matter. So we are just multiplying 5 5s together. Yeah. So that's why this rule works. And then this one, this is x over x to the power of a over x to the power of b is equal to x to the power of a minus b. So this is like going back, because dividing is kind of like the reverse of multiplication. Okay. So we are at we have done 5 seasons. We want to check back 2 seasons ago how many potatoes did we have. Then we do 5 minus 2 here. Yeah. And this will be equivalent to 5 to the power of 5 over 5 to the power of 2. And this will be equal to 5 to the power of 3. And why is this a fraction? So look at this, 5 to the power of 5 on the denominator, and 5 to the power of 2 in the denominator. Just like in fraction, we can simplify this. 2 5s are cancelled on both the denominator and denominator, and we are left with 3 5s. That's why it's 5 to the power of 3. Okay. Or it can be minus, it can be subtracted like this. Okay. And the next one. What if we are doing power of 0? What does that mean? Okay. So to the power of 0, if you look back, this power is what happened after that number of seasons. After 1 season is 5 to the power of 1. After 2 seasons is 5 to the power of 2. Which means if we have 0 here, it is after the 0th season. Which means we haven't planted the potato, but we have already bought the first potato, or the initial number of potato. In this case 1, because we do not see the initial value, so it is 1 times, is 1 here, the initial value. Okay. So which means for any numbers here at the base, this is also called the base of the indice 5, or the exponential factor 5. 5 to the power of 0 is 1, because we didn't plant the potato here. It's 1 time, it's like, this is 1 times 5 times 5, this is 1 times 5, then the previous one will be 1, right? Yeah, because we didn't plant the potato. So then we have 1 here, even though it is x, which means it can be 4, it can be 3, it can be 2, doesn't matter. We will still get 1, because the initial value is 1. Okay. Also true for negative numbers. Okay. So for negative numbers, this is like an exponential increase in loss. So you can imagine, like, okay, this is a country that in which people feed on potato, and the population of this country is increasing exponentially, which means potatoes will be consumed as exponentially, right? So, but this is 0 on the power, so it's still 1. Oh, how about 0 to the power of 0? 1. What happened here? How did we make something? How do we create something? This is 1, this is a value, but this is all 0. There should be nothing here. So what happened? Oh, this is in this form, right? So which means there is an initial value. We bought the 1 potato. Okay. We bought the 1 potato. However, the exponential factor is 0. The base is 0, right? It means that the field gives nothing back. The field does not multiply, even if we try to plant the potato in there. Maybe some conditions are not suitable. Maybe pH is too high or too low. Maybe the nutrients is not suitable. Yeah. So no matter how many seasons we do this, we still get nothing back. We'll get 0 potato. This is 1 times 0 to the power of 2. We try to do everything we can for 2 seasons, and we are still getting nothing back. The potato is gone. The potatoes get absorbed by the soil. Okay. However, if we do it for 0 seasons, oh, the potato is saved because we did not plant it. This is 1 season. This is 0 season. We did not plant the potato, so the potato is saved. And that's why we have 1. Okay. In here, the initial value 1 times is omitted, just like here, because 1 times does nothing. But if the initial value is 2 or other numbers than 1, then we have to show it. So it's not shown here because it's 1 times. So just like doing this here. Okay. Alright. So for the next one. Oh, what if we have power of negative numbers? What does that mean? What does that mean by doing this for negative number of seasons? Yeah. So we can do this by looking at the patterns. So whenever there's a season increase, it is multiplied by 5, right? Or multiplied by the exponential factor. Okay. So let's say here to here is times 5, and then 2 to 3 also times 5. Okay, and if we go back from season 3 to season 2, is times 1/5. Okay, 125 times 1/5 is 25, or 5 to the power of 3 times 1/5 is 5 to the power of 2. Okay, and then we go back 1 season. Then it's multiplied by 1/5. Okay, so here to here is multiplied by 1/5. Okay, so then we keep going back from 5 to the power of 1 to 5 to the power of 0 is also multiplied by 1/5, right? So from 5 to the power of 1, and then 5 to the power of 0, and then 5 to the power of -1. From here to here, 5 multiplied by 1 over 5 is 5 to the power of 0, but this is 1. This is essentially 1. This is 5. So this time 1 over 5 is this one, which means from this one to this one, it should also be multiplied by 1 over 5. So this one will be a 1 over 5. And the next one, if you continue the pattern, then multiply by 1 over 5 again, be 1 over 25, or 1 over 5 square. So that's why the rules is like this. So 5 to the power of -1 is 1 over 5 to the power of 1. 5 to the power of -2 is 1 over 5 to the power of 2. Or 5 can be any number, x, can be 4, can be 3, can be 6, can be negative numbers. So, and then in the end, we generalize that 5 to the power of -n is 1 over 5 to the power of n. Or more generally, x to the power of -n is equal to 1 over x to the power of n. Okay. And we have our first in this video. See you in the second in this video and the tutorial of this video.